about the best I've done so far. I have it running on a statpower inverter. It's 1/3 horsepower marathon motor, rotovertor setup. It's drawing 50 milliamps from the inverter AC into the rotovertor. The run cap phase right now is 3.5 UF, which means you have very low draw and not so much going into the load, but into the battery it says 0.08, so 80 milliamps into this battery. It's in DC, and it's from the full-way bridge rectifier to the battery. The battery reads 12 volts, and it's been like this for 5 minutes or so. And I had to start it with just a 2 UF cap. I had a video about this before. These statpowers, to get them going, you have to have a 2 UF for this particular motor. And then once I get it going, I can add or subtract run cap values. And I put it up to 3.5, which has been where I get 20 milliamps when it's just running with no load on it. So like I said, it's been pretty steady here. Battery's receiving 80 milliamps. The inverter's putting out 50 milliamps. And what's coming out of the battery in DC into the inverter, I'm going to leave that a mystery, because I think there's something going on when you ram power into the motor. You actually subtract what it needs to run. But I know that this inverter, to run this thing, takes half the power of a normal inverter, and it's 430 milliamps at 12 volts. Excuse me, 43 milliamps at 12 volts. Is that right? I don't know. Half the power. I think it's 430. Sorry. 430 milliamps. This thing draws from a battery to run this motor. If you just have a battery powering the inverter running this. I have some videos about 3 or 4 back. I can confirm that. So, but this battery's staying real steady Eddie. And like I say, I don't want to even know the DC coming out of here, because that means it's all for naught. But getting this battery not to sink is something good. There's something very interesting. I don't really want to show it right now because I'd have to take all this apart, and it's working good. See, it's still steady at 12. And what it is you take this transformer, you put it in series between the L2 line and it goes to one side of this cap, the run cap, and the L3 line goes back to the motor. It's the basic, you know, rotovertor run cap phase thing. And so between the L2 and the cap is where I attach this transformer in series. It's not parallel this time. And what's cool, very cool, is you'll have a lot of amps if you don't, the other side of this transformer, if you have nothing on it at all, you get this huge draw over here. You'll get like 300 milliamps going into it instead of 20, which is what you have when the run cap phase is just right and there's no load. Or you don't have 50, but instead you have like 310 milliamps. I'm just telling you what it does. Now, what you do is you short out this other side of the transformer, touch them together, and the draw over here into the motor, this is if I'm running it off the grid, you know, first test. The draw over here goes down all the way to 20 milliamps when you short out the other end. So if you think about it, so that just means if you have a heavy resistive load of low impedance over here, it's similar to a short. This is still at 12. Look at that. And so that's where I hooked up the full wave bridge rectifier AC side of it, and the DC side goes right into the battery. And I checked the voltage of the full wave bridge rectifier when it's not going into the battery, just the voltage coming out of the DC side of the full wave bridge connected to this transformer, which is actually stepping it up from 3.5 to 9.9, and it's like 15.4 volts, which is good. So that means I can charge a battery with it. So that's what I did. I put the battery connected to the DC side of the full wave bridge. Beeper went off, but it's just the meter turning off. Inverter's still going good. So I am very happy it's not sinking in voltage. I know that it is receiving a charge of 80 milliamps and 15 volts. And I know that between the inverter and the motor, it's 50 milliamps. And I don't think I could do this if I used a regular inverter. I don't think it would work so well. I think that voltage on the battery would be dropping. Earlier, I tried all of these, like all in parallel on the high voltage side. On the DC side, low voltage side, I hooked them in series, and I had like 18 volts, and I was charging a battery, and I looped it. I filmed it, but I'm not going to post it because it's such a mess, but it made the battery just go, whoo, just suck down so fast. And I tried all sorts of caps with it. And, but I think this is working good right now. Perhaps changing this for a supercapacitor might be something cool. Maybe it'll ruin everything. Okay, I'm going to, just for my own good so I remember what I'm doing, coming off, when anybody wants to do it, I'm going to say what I'm doing one more time. Coming off the L2 line is a transformer in series at 3.5 ohms. And one side of this transformer is connected to the cap, and the other side's connected to the L2 line. Okay, so that's it. It's not the L3 line. Usually I do a series cap on the L3 line, but I did this on the L2 line. That might be why it's working so good. I don't know. So, now, I think this is called a vector, a transformer in vector configuration, but I don't know, but it's in series. It's not parallel to the run cap. Now I take the output of 9.9 ohms, run it into a full wave bridge rectifier. Like I said, this is 15.4 amps, and if you short this out, the draw goes from 310 milliamps down to 2. So that's where you see something that's like, it probably is normal, but it's not normal. That shorten that out makes the draw go down so drastically. Let's see if it's still 12. Look at that, it's still 12 all this time. Okay, so now I am charging the battery from the DC side of the full wave bridge rectifier down here. And then from the battery, positive, negative, I run that into the statpower inverter, and then I quickly shoved the input of the rotovertor motor into the statpower inverter, and it's still working. I haven't blown it up. I'm so worried about blowing these things up, but I guess I don't have to worry. So here we go, 12, 12, 12, 12. I think that's about it. It's pretty good for once. So, if this was drawing 430 milliamps, I know that this inverter and another one I have, it's normal ones, they take 1 amp and 12 volts, 12 watts. These take just to spin this thing, okay? And this thing's got ceramic bearings, it's super low draw. But this one is less than half the draw, it's 430 milliamps. And if this is all true, we would be sucking out of this battery about 6 watts. 6 watts is being sucked out of that battery to run this inverter. But it doesn't seem like 6 watts is being taken out of this battery because it's staying steady. Hector says something about hyperwaves is what charges the battery when you got it in loop condition, but I don't know. So, like I say, I'm not even going to look at this because I don't think it's going to be like a skeptic or somebody saying I'm full of it. They'll say, hey, what's the DC coming out of it into the inverter compared to the DC going into it? You know? And, well, it looks like the DC's about the same because I don't think it's drawing 6 watts. It would be going down. So, it's all good, I guess. Now, if I had a super cap here, it would be quite good. Alright, I guess I've talked enough. Okay, thanks for watching.